Recall, the product of two real numbers, a times b, is less than or equal to 0 if and only if 1. Either a is less than 0 and b is greater than or equal to 0, or number 2, we have a is greater than or equal to 0 and b is strictly less than 0. Notice that we can also allow equality here and allow equality here, no problem. Okay, because if a is 0 and b is 0, you have b and 0 times 0 is equal to 0. So again, if a is 0 and b is 0, we have 0 multiplied by 0, which is again 0. So that is not an issue. So these are two conditions under which we have the product of two numbers being less than or equal to 0. And we have that situation in our hands where we want to solve this problem. T plus 2 multiplied by t minus 2 is less than or equal to 0. So I take t plus 2 as my a, t plus minus 2 as my b. So we want to find all t such that this is true. And therefore we consider these two cases. So case number 1. We want to assume first that t plus 2 is less than 0 and t minus 2 is bigger than or equal to 0. We find the values of t in this situation. If this is true, this means that t is less than minus 2 and t is greater than or equal to 2. Let's graph this set. This is the number line. This is 0. This is 2. This is minus 2. T less than negative 2, we have this side of the inequality. So this is the graph. T greater than or equal to 2, we have, this is the graph. Now, in set theory, if I say set A and set B, this simply means set A of the intersection of the two sets A and B. And therefore, I have this set, the set of all t less than minus 1, minus 2, and the set of all t greater than or equal to 2. So I take the intersection. If you look at the graph I have, there is no intersection between this set and the other set. So the first case generates an empty set for us. Meaning, you cannot get any two real numbers satisfying this and satisfying that, such that this is true. So in that case, the solution set is empty. I hope this explanation makes sense. Yes, it does. For the second case, we're looking at when t plus 2 is bigger than or equal to 0 and t minus 2 is strictly smaller than 0. We solve again. T plus 2 greater than 0. What does it mean? This means that t is greater than or equal to minus 2. And this other case says that t is strictly smaller than minus 2. Strictly smaller than positive 2. That's right. So if again we graph this, this is 0, this is negative 2, this is 2. All t greater than or equal to minus 2, I am here. It goes to plus infinity. All t smaller than 2 is here. This goes again to negative infinity. If we take the intersection between this set and this set, we shall get, so let me make amendment here. So this has to be 2, please pardon that. So, if we take the intersection between all t greater than or equal to minus 2 and all t less than or equal to 2, the intersection is simply this set. And what is that set? It is the set minus 2, 2. Therefore, the domain of our function h is simply the interval -2, 2.